Hello everyone, welcome back to another episode of Solving LEETCODE Hard Question. Today's question is substring with concatenation of all words. The question is as follows. You're given a string S and an array of strings words. All the strings of words are of the same length. This is important here. A concatenated string is a string that exactly contains all the strings of any permutation of words concatenated. Return an array of the starting indices of all the concatenated substring in S. You can return the answer in any order. So for example, if the input is bar foo the foo bar man and the words are foo and bar, then the output would be 0 and 9. This is because at index 0, the substring bar foo is a concatenated string of the words foo and bar. And at index 9, we have the substring foo bar. And again, it's a concatenated string of the words foo and bar because foo and bar each appears once. How do we solve this? Pause the video here if you like to think independently for a moment. We previously emphasized that all the words have the same length. For example, the words foo and bar both have the length of 3. So we know how many words there are. Let's call it K. And we know how long each word is. Let's call it W. Then we can calculate the length of a concatenated string, which is K times W, and we'll call it P. This leads to our step 1. Given the substring of the same length P, we can check if it is a concatenation of all the words. If we can do that, we can repeat step 1 for all the substrings of length P in the original string S. Here we have an example with the substring bar foo and the words are foo bar. The tip here is to use hash maps. This allows us to map each word to their frequencies. And we can look up if the substring contains this word easily and decrement its frequency if the word has been found. The idea here is to split the substring by the length of each word. So the first word is bar, and bar is in the frequency map. So we decrement the frequency of bar by 1 to 0. And the second word in the substring is foo. And foo is also in the word's frequency map. So this also gets decremented to 0. At the end, if the word's frequency map is all 0, we know that each word has appeared exactly once in the substring. And this substring is a valid concatenated string. This is the Python code of the function we just discussed. First, we'll create a copy of the hash map. This is because we'll need to reuse the word's frequency map in step 2. Then, for each word in the substring, we'll check if it exists in the hash map. If it does, we'll decrement its frequency by 1. Otherwise, we can only return false. This is because a concatenated string has to have all the words and only those words. At the end, we'll check the hash map again and verify that all the words have frequencies of 0. If not, we'll return false. The time complexity of this function is O of k, as we're checking k words in the substring. And the space complexity is O k times W, which is the length of the substring and approximately the size needed for the hash map. Moving on to step 2. We need to get all the substrings of length P in the input string S and check if they are a valid concatenated string. This is the easier part. We can just use a sliding window, moving one step at a time. So for example, if the input string is bar foo the foo bar man, then we'll start at the beginning, get the first substring bar foo. Call the function in step 1 to check if it's a valid concatenated string. Then move on to the second substring, rfoot. Again, call the function in step 1, then rinse and repeat until we reach to the end. Putting everything together, this is the Python code. First, we'll construct the word's frequency map. Then we'll use the sliding window technique to check for each substring of length p in the input string. The final time complexity is O n times k. N comes from using the sliding window, and k comes from checking for each substring. The final space complexity is OK times W, or P, which is the size of the hash map. This is already a very solid solution, but can you think of any optimizations? Here are some possible ideas. The first idea is to cache the valid or invalid substrings. This works best if the input string has many identical substrings. If we cache the already seen substrings, and we encounter an identical substring, then we can skip the processing because we already know the verdict of this identical substring. The second idea is to jump by word length when the word count is over. If a word has appeared more times than it should be, we might be able to jump by the entire first word or even more to speed up the iteration. This will require some restructuring of the sliding window technique. Give it a try and let me know what you think. That's all for today. Thank you for watching.